Now, multiplication, I have several multiplications for you to show you. In this case, we're multiplying two purely imaginary numbers, the square root of -2 times the square root of -10. I can think of two ways to do this. But there's only one way that's going to make sense with our physical applications that we have, that you're not going to see in this class, but you might if you get into physics or engineering. And the only way that makes sense is to poke the eyes out first. Okay? It's the only way that actually works with what and does what we want it to. So before you do anything else, so in other words, I don't want you using the real number property that when you take the square root of a times the square root of b, you get the big square root of a times b. In fact, that doesn't work when a or b is less than 0. That property actually doesn't hold. So I'll put a not equal to when a and b are less than 0. So poke the eyes out first. What do you get? I times root 2 times I times root 10. Now reorder the multiplication. In the middle, you can make it I times I. Whoops, let me write it as I times I. And then square root of 2 times square root of 10. Now when a and b, the guys underneath the radicals, are bigger than 0, you can go ahead and combine into one big radical, can't you? So you could make the square root of 2 times the square root of 10 the square root of 20. What is I times I? I squared. So I squared is -1. And also we should simplify root 20. So 20 is 4 times 5, right? So you can pull out a square root of 4 or 2. So this is going to simplify to be -1 times the square root of 4 times 5. But you can pull out a factor of 2, square root of 4. What's -1 times the square root of 4? It's -2. So you get -2 root 5 is your answer. Part D, we're taking a real number, 3, and multiplying times a complex number, a true complex number, 5 minus 12i. So what do you think we have to do with that 3 here? Distribute the 3. The distribution property works for complex numbers just like it works for every other number, every other set of numbers you've looked at. Okay, so multiply out the 3. What do you get? 15 minus 36i. 3 times 5, distribute it, 3 times the 5, and then distribute the 3 over the minus 12i. 3 times 12i is 36i. So 15 minus 36i. Let me show you how to multiply two complex numbers together. If you had to guess, what would you do? You would do good old FOIL, right? Yeah. And FOIL really is just distribution, right? So we're going to distribute every individual term in the first factor times every term in the second factor. But if you want to, think of it as FOIL. Multiply the first together, what do you get? 3. Multiply the outer together, what do you get? Keep the operation, so plus 5i. Multiply the inner together, what do you get? Minus 9i. Finally, multiply the last together. Minus, oh, careful, minus 3i distribute over a plus 5i. So minus 15i squared. And then the trick is you have to remember I squared is -1. So, okay, like terms in the middle. What's 5i minus 9i? Whoops. Let's make it a minus there. So minus 4i in the middle. And then minus 15 times -1. Right? Did everybody see what I did? I replaced the I squared with -1. And so you get 3 minus 4i plus 15. You see any like terms there? So 18 minus 4i.